All right, I'm going to be on page 9 of the notes. We're going to be talking about the domain and range of trig functions. So remember that every trig function is a ratio, it's a fraction. So the domain is going to be restricted if we ever have to divide by 0. So we're going to go around the unit circle and kind of look at these values and see where would this function be undefined because we divided by 0. So sine and cosine, we're dividing both y and x by the radius here. Since the radius can never equal 0, then the domain of both sine and cosine is going to be all real numbers. And so the range, we want to think about what numbers we have as we go around the unit circle. So as we go through, we have all the values of 1/2, root 3 over 3, root 2 over 2, and those values just repeat. And then we have on the axes, we have 1 and 0. So we basically have all the numbers between -1 and 1, because all those fractions that we have in the quadrants, those are all less than 1 but greater than 0. So all of our values are going to be -1 to 1. The lowest value for y is always -1 and the highest is 1. So that's how we're going to figure out what our range is for sine and cosine. Tangent and secant is a little different because in the denominator we have x in both of them. So they're going to be undefined wherever x is equal to 0 on the unit circle, which is going to happen at this spot up here and this spot down here. So if we think about those values in radians, up top would be pi over 2, and on the bottom that would be 3 pi over 2. So it's going to be undefined in those two places. So the domain of both tangent and secant is going to be the set of all numbers except odd multiples of pi over 2. So thinking like anywhere, since we can keep rotating all the way around and we can have so many coterminal angles, if I have pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and keep going like that, as long as it's an odd number, then that means that is going to be excluded from the domain of these functions. So then for cotangent and cosecant, since we have y in the denominator, we're going to take that same thinking, and anywhere that we have y equal to 0 on the unit circle, those values are going to be undefined. So at this first spot, that's 0, or we can call it 2 pi. Over here, this is pi. So we're going to go ahead and say that happens at 0 and 2 pi. Nope, sorry, 0 and pi on the unit circle. Therefore, the domain of tangent and secant is a set of all numbers except integer multiples of pi. Integer multiples meaning it's not a fraction, so it's like 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, as we keep rotating around the circle. So the range of secant and cosecant, those are the reciprocal. I'm just going to add a little note that those are the reciprocal of sine and cosine. So if we're thinking about the reciprocal of the range that we had for sine and cosine, we're going to have negative infinity to -1 with a square bracket, union 1 to infinity. And we can talk more about where that comes from, but I'm just going to have you just know that for right now. And then the domain or the range of tangent and cotangent. So we can go all the way from negative infinity to positive infinity for the range of tangent and cotangent. All right, so for periods of trig functions, so a period is basically meaning like how long does it take for the values to start repeating as we rotate around the circle. So we can call it periodic if there is a value p with the property that we can do theta plus p is the same thing as theta. So that's kind of like how we've been finding coterminal angles, and we've been saying that the terminal side lands in the exact same spot. That's what we're talking about when we're saying it has a period. So sine, cosine, cosecant, and secant all have a period of 2 pi. And so this is just the notation is kind of weird, but it's just saying that if I were to add 2 pi to my angle, I would be in the exact same spot. I would have the same sine value. And same thing for cosine, cosecant, and secant. Tangent and cotangent. Oh wow, this is bad. I just realized there was a typo. So these should be pi. So tangent and cotangent have a period of pi. So every pi radians, it's going to start repeating again. So tangent and cotangent have a period of pi, while the others all have a period of 2 pi. All right, so if we want to find the exact value of the following angles, we've already done this kind of thing. If we see that we have 17 pi over 4, that's not a value we have on the unit circle, but we can subtract its full period to figure out something on the unit circle so we can actually answer this question. So if we think about 17 pi over 4, and I want to figure out what a coterminal angle is, I can subtract by a full rotation, which is 2 pi. So I have to get a common denominator in order to actually do anything with this. So since this one has a denominator of 4, I'm going to multiply the top and bottom of this one by 4, which would give me 8 pi over 4. So I would end up with 9 pi over 4, which still is not on the unit circle. So we're going to take that value we subtracted and subtract it again, pi over 4. And remember, this is just subtracting full rotations on the unit circle. We're not changing anything. We're just making it so we actually know the value that's on the unit circle. So I would end up with pi over 4. So now instead of needing to know what 17 pi over 4 is, I can just figure out what is sine of pi over 4. And we can say it's plus 4 pi in this situation because we subtracted 4 pi. So then I just have to think about what is the y value of the radian angle pi over 4, which would be root 2 over 2. Okay, so for cosine of 5 pi, again, I'm thinking I don't have 5 pi on the unit circle, so I'm going to try to subtract full periods. So I could subtract 2 pi. I don't have to get a common denominator because it's not a fraction, so that would be 3 pi. Subtract 2 pi again, and I would get pi. So I can rewrite this. Again, I subtracted 2 full rotations, so I could say I end up with pi, and I subtracted 4 pi, so I would say plus 4 pi. And that might be easier to see than the fraction for y'all because pi plus 4 pi is obviously 5 pi. And so we're going to think about what is cosine of pi. Cosine of pi. So cosine of pi is going to be equal to -1. Okay, and then tangent has a period of pi. So we can think about if I have 5 pi over 4, which is just a value on the unit circle, so I could figure that out, which would equal 1. But I can also figure out that if I were to subtract pi, get a common denominator, that would be pi over 4. And at pi over 4, I would have also 1. So it takes pi rotations to repeat. Unlike the full rotation we need for sine and cosine, we only need to rotate half the circle to start repeating our tangent values again. Okay, so finding quadrant given signs of trig functions. So we've talked about this a little bit before. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in quadrant 1, all of our trig functions are positive, and we have the ordered pair where they're both positive. Both x and y are positive, which means all the trig functions are positive. In the second quadrant, we have where sine and cosecant are positive, meaning all the other ones are going to be negative. So we have the ordered pair negative, positive. And then for the third quadrant, we have tangent and cotangent that are negative. I'm sorry, positive. And we have negative to negative. And then in the fourth quadrant, cosine and secant is positive. The rest are negative, and we have the ordered pair positive, negative. So I think I already told y'all this, a way to remember like the order of them, if we think about all students take calculus, and we think about the all S would be sine, take would be tangent, and C would be calculus or cosine. And that's a way to remember which trig functions are positive in which quadrant. And so it's the trig function and its reciprocal. So if we're given a problem where we're given that tangent is less than 0, meaning tangent is negative, and cosine is greater than 0, meaning it's positive, we need to be able to say what quadrant that angle is going to be in. So what we want to do is we want to draw a XY grid, and if tangent is negative, that's going to happen in quadrant 2 and quadrant 4. So every trig function is going to be positive in 2 quadrants and negative in 2 quadrants. So then if I think about cosine is greater than 0 in quadrant 1, and it's greater than 0 in quadrant 4. So we're looking for where our two things overlap. So in quadrant 4 is where we overlap, so that would be my answer. So same thinking for the next one. I'm going to draw my grid. So I have sine is less than 0, meaning sine is negative. So that's going to happen in quadrants 3 and quadrant 4. And cosine is greater than 0 in quadrant 1 and quadrant 4. So again, my overlapping quadrant is going to be quadrant 4. All right, if sine of theta is greater than 0, so sine is greater than 0 in quadrant 1. Everything's positive in quadrant 1. And then in quadrant 2, sine is also positive. And then for cotangent, so cotangent is positive, or sorry, it says negative. So cotangent is going to be negative in quadrant 2 and quadrant 4. So we would say they overlap in quadrant 2. All right, if cosecant is less than 0, so we're gonna go ahead and do that. And we can think about too, like if you don't memorize where each thing is, as long as you memorize the ratio, like cosecant is the reciprocal of sine. So that would be 1 over y. And then cosine is just x. So if we think about where is y negative, that's going to happen in the bottom because that's where our y-axis is negative. And then if we're thinking about where is x negative, that's going to happen to the left. And so that's where I'm like getting all this shading if I'm going too fast with that. Um, but we're going to go ahead and circle this part. So our answer would be quadrant 3. All right, and then last thing is just review of finding exact values not on the unit circle. So remember that if we're given sine of theta, that means we're given y over r. So what I'm going to do is I'm going to go ahead and set up that I have x equals, we don't know, y equals 1, and r equals 3. And it says that cosine is negative, so that means that when I find my x value, I need to make sure it's negative. And we can use the Pythagorean theorem to find what x is going to be. So I'm going to say x squared plus 1 squared equals 3 squared. So I would have x squared equals, this is just 1 and this is 9. So 9 minus 1 is 8. Take the square root of both sides. I would have x equals, and I want to simplify this. So I can break it down to the perfect square of 4, and I'm left with 2. The square root of 4 is 2, and I would just still have that square root 2 left inside. And we said it needed to be negative, so just make sure you include that negative because of this information right here. So then final part of this is to find the exact value of the remaining 5 trig functions. So we already found sine, so cosine of theta is going to be x over r, so we would have negative 2 root 2 over 3. Tangent of theta is y over x. So we're going to have 1 over negative 2 root 2. And then we're going to have to rationalize that. So we're going to say, we're going to multiply the top and bottom by square root 2, which would give me square root 2 on the top. It's a negative. And we're going to have 4 on the bottom. And I think I've gone through this a few times in class, but I'm going to go ahead and just like do this step by step if anyone is feeling lost on how to rationalize. Whenever you have a radical in the denominator, we want to multiply the top and bottom by that radical. So on the top, I would end up with just square root 2 because 1 times square root 2 is square root 2. We still have that negative. And then when I multiply radicals with the same radicand, meaning what's under the radicals just go away and we would just have 2 left over. So I would end up with negative 2 times 2 on the bottom, which would give me 4. All right, and then for the next one, so we have cosecant of theta. Cosecant is the reciprocal of sine. We can just take our sine function, flip it over, which would just give me 3. Secant of theta is the reciprocal of cosine. So I'm going to flip that over, 3 over negative 2 root 2, and then I need to rationalize it. So multiply the top and bottom by square root 2, which would give me 3 square root 2 over, and I would just cancel the radicals, so I would have 2 times 2, which would give me 4. And then last one is cotangent. Cotangent of theta is the reciprocal of tangent. So if I flip tangent over, it's easiest to go back to when I didn't rationalize, because otherwise I'm going to have to rationalize again when I flip this fraction over. So I could just flip the 1 over negative 2 root 2, and I would just get negative 2 root 2. All right, one more review of these is given tangent and sine is less than 0. So I'm given tangent, which is y over x. So I'm given that x is equal to 2, y is equal to 1, and r is equal to, I don't know. Sine is negative, it says. So if my y value is negative and my tangent here is positive, if I plug a negative y in, the only way to make that tangent positive is if x is also negative. So I need to add a negative to my x also. Then I'm going to use the Pythagorean theorem. So I'm going to have x squared, which is 4, plus y squared, which was 1, equals r squared. So I would have 5 equals r squared. Take the square root of both sides, so r would equal the square root of 5. All right, and then setting up our trig ratios. So sine of theta is y over r, so I would get -1 over square root 5. And I would need to rationalize, so I would multiply the top and bottom by square root 5, which would give me negative square root 5 over 5. If I have cosine of theta, I would have x over r, so -2 over root 5. Multiply the top and bottom by root 5, which would give me -2 root 5 over 5. And then tangent, where we get that one, we were given tangent of theta equals 1/2. So then if I want to do the reciprocals, I have cosecant of theta. I would flip this fraction, so I don't have to rationalize again, so I would just have negative root 5. Secant of theta, again, I would just flip over the unrationalized one, which would give me negative root 5 over 2. And then cotangent of theta is the reciprocal of tangent, which is just 2. All right, that's it for the notes. I will have office hours today, so if you have any questions, feel free to pop on and ask.